This is a very quick screencast to compare and contrast two different approaches to accessing geospatial data from the IODP resources. Now this screencast is going to focus on accessing data not through OGC style client services using WFS or WMS type services, rather focus on lighter weight REST style access to data. And to this approach there are two aspects that we're contrasting. One is looking at the geospatial SPARQL calls against RDF graphs. In our case, looking at calling into our Virtuoso server. Now, it should be noted that the geospatial extensions of SPARQL are not yet standard. There is work going on in that direction, and at present, the Virtuoso server and implementation of the geospatial calls is following that approach, the current approach that's being worked on. Should a standard be released soon, Virtuoso has said they would abide by that standard and alter their SPARQL calls in that regard. So, nonetheless, a SPARQL call right now that's geospatially enabled is rather simple. Basically, what we do is a standard type query into our graphs. In this case, I'm going to call into the Janus H model graph. And we simply can call in their built-in functions to make geospatial calls. So in this case, we're looking at particular lat long and then a distance from that point for the calls that we want to make. So if we fire this call off against our server, then we can get a set of solution URIs that we could then call to receive the age depth pairs or any other type of reference data in our graphs, be it publications or lithology or other components around those geospatial calls, and then the actual geospatial lat long point that satisfied that query. So very simple, very straightforward, very fast calls into that environment. Now, the other geospatial approach that I've been looking at is actually leveraging the Google Fusion tables. So I've loaded data into the Google Fusion tables, and this allows you then to begin to make queries into that using a standard REST-based API, both for authenticated and unauthenticated calls into that environment. In this example, we'll be dealing completely with unauthenticated calls. The query language is far more SQL-like in this environment than the SPARQL calls, good or bad depending on how you want to look at that. Same type of call that I'm doing here. Taking a point, a lat long point, and then a radius from that, so drawing out a circular point from a selection, and then querying back the information that comes from there. So in that case, a call would look something like this, right? Here I'm just using simple command line curl call. Obviously, in both cases, since this is just HTTP REST type calls, any language, any package that you want to use to conduct these types of queries is completely valid. No difference or benefits in either approach in that regard. And here we have the select statement that we use. So select from a particular table, an intersection, a circular with a lat long, and a radius, exactly analogous to the approach that we took in the SPARQL RDF calls. So something like this then, when we conduct that query, we just get the information back. So some advantages to Google, of course, is that incredible reliability, incredible scalability in terms of making those calls versus running our own RDF triple server and rely upon the reliability of our own architecture, which could be completely fine. But of course, Google's going to have a very good reputation at uptimes in that regards. One thing I don't like about the Fusion tables, though, is that at present the only data type that we can return is CSV, separated data values. We do get the header list at the top, so we know what the headers are, but we're parsing CSV. When querying into the Virtuoso server through SPARQL, we have the ability to request CSV, JSON, a native XML, HTML, other types of formats that are really nice to see. Obviously, we could put a vent pipe type proxy in front of this and convert this CSV to any format that we wished if we wanted to, but that of course defeats the advantages of scalability and uptime that the Google type approach would give to us. So really, just in conclusion, this is a very simple comparison of geospatially enabled SPARQL queries and geospatial fusion table calls, Google Fusion table calls.